Welcome everyone. Today we are kicking off a brand new series on system design. Whether you are preparing for interviews, looking on real world projects, or simply curious about how large scale applications come together. So, what is system design? Imagine creating the entire blueprint for an application that millions rely on every day, like Instagram, Netflix, or Uber. It is not just about writing code, it's about designing every detail to make sure they work seamlessly, scale effortlessly, and adapt to millions of users. And to add to that challenge, everything needs to be fast, reliable, and secure. Over the next many videos, we will break down the complex into simple. We will start with fundamental concepts, understanding how we handle loads of data, design for scaling, manage databases, and optimize network calls. Then, as we build on this foundation, we will dive into designing full systems similar to the popular services. Today, we will try to understand what system design is, why it matters, and how it applies to both technical interviews and real world applications. So, let us start with what is system design. System design is a process of planning large scale applications that can handle complex requirements. Those applications should handle massive amounts of data and the dynamic needs of the user. It's about seeing the big picture on how different parts of a system will work together, communicate, and grow over the time. Designing a system goes beyond coding. It involves defining how every component from database and APIs to networking and caching will function seamlessly. In simple terms, think of system design as a blueprint or architecture of an entire application. The goal is to make sure it's structurally sound, scalable, and efficient from ground up. System design is a must-have skill for developers and architects, especially in the interviews for mid to senior and lead technical roles. Companies rely on robust, scalable systems, and they want to know if you can think at that level. In these interviews, they want to see if you can break down complex requirements, understand trade-offs, and make efficient choices. Interviewers assesses your ability to design a solution that can grow as the user base or the data volume increases. For example, how would you design an online bookstore to handle millions of users, each viewing and ordering multiple books? They look at how you visualize different components interacting, like database, caches, and external services. For example, if designing a chat application, you would need to think about how messages get sent, received, stored, and synced across devices in real time. They also want to see if you can design the application for failure. For example, if there is a surge in user on New Year's Eve on a social media platform, how would your design keep the app from crashing? In real world applications, system design is essential because it defines how software works at scale. Great system design can keep the application running smoothly even under extreme conditions, ensuring speed, reliability, and user satisfaction. Let us understand some key reasons why system design is critical in practice. The first key point is high traffic and scaling. In your application, as the user base grows, system needs to handle more requests without slowing down or crashing. Think about a streaming service like Netflix. Millions of users may be streaming at a given time. If Netflix system wasn't designed to handle such load, videos could lag or crash frequently. To prevent this, Netflix architecture uses content delivery networks to cache the data closer to the user. That reduces the load on central servers, making the overall system more robust. System design also involves structuring data efficiently for fast access, storage, and backup. For an e-commerce website, data about users, orders, and inventory must be stored in a way that's easy to access, modify, and expand. Here, a NoSQL database like Cassandra could help with the quick retrieval of order histories, while an SQL database might be ideal for inventory transactions to ensure the consistency. Real-world systems must be reliable and available to the users all the time, even during peak hours. Imagine in a food delivery app, users depend on it to place the orders, track deliveries, and contact the delivery agents. If their system isn't designed with the redundancies and backup mechanisms, a single server failure could cause widespread outage. To ensure high availability, application owners might replicate data across multiple data centers to protect against the regional outages. Users expect fast response when using apps. Designing system properly will address the latency to ensure requests are processed quickly. In an online gaming app, milliseconds can make a huge difference. For a smooth user experience, game servers might be placed worldwide in such a way that it offers low latency that allows the player from different regions to interact seamlessly. Security is also a very critical aspect of any system, especially with the rise of cyber attacks. Security features needs to be embedded within the architecture itself. For example, for an online banking system, each user's sensitive data must be protected. This is where designing with encryption and secure authentication systems like OAuth or multi-factor authentication becomes essential. Good system design consider cost as a key factor, choosing cost-effective technologies without sacrificing performance. I hope now you have the basic understanding of why do we really need to understand how the system is designed. System design at its core is about creating an application architecture that balances scalability, reliability, efficiency, security, and cost. Whether for an interview or a production application, understanding how to design these systems gives you the power to create softwares that can stand up to the real world demands. With each upcoming videos, we will explore these topics in more depth by tackling one design concept at a time. So stay tuned and let us continue our journey into the system design together. If you like the video, please don't forget to like, share and subscribe. Also, don't forget to press the bell icon so that you won't miss any new update on the new videos of system design. I'll see you in the next video. Till then, keep learning.